Hi, okay, welcome back. This is forces number 2. So, first video we looked at some base understanding of forces and acceleration and the definition of the Newton. Now we're going to look at the kind of complex situations that you get at AS level physics. So, most common one is things on a ramp. So we've got an object on a ramp that has a mass, that has a weight, of 200 newtons. Okay, weight of 200 newtons. Then we'll say that the ramp is at an angle of 22 degrees. The questions that often get asked around this are to do with what's happening down the slope. We've got a car on the slope and it's travelling down the slope. So we've got a force of 200 newtons going directly down. So my first question is, what is the force down the ramp? Okay, what is the force down the ramp? So, what we can work out here is, we've got a situation where we've got 200 newtons that's on a ramp that's at 22 degrees. Now, there is an angle and essentially two sides, so it's a triangle situation. Now, most of you will make this mistake. And the reason I put it in this video is that most people make this mistake. They often look, right, we need to do a vector resolution, so they do something that looks like this. And that's the side they want to find out. That is absolutely wrong, okay? It's absolutely wrong. Because that is saying that this force here gives rise to this one and this one. Now that's a load of nonsense. It's this force here, the weight, that gives rise to the force down the ramp, so it cannot be the hypotenuse of that triangle. So how should I draw my vector triangle for this situation? Because it looks so easy to do that way. Well, this is the way you should do it all the time. You should remember, in most cases, the weight, or the force due to gravity, or acceleration due to gravity, is the hypotenuse of the triangle. So how can I draw a triangle on this that makes that side the hypotenuse? This is how you do it. So now we've got a right angled triangle. There's our right angle. We've got our 200 newtons on this side. And this value right here is going to be our force down the slope. It's going to be our force down the slope. However, how can I work this out? Because I've only got one side here and my angle's all the way over here. Well, let's do some geometry to actually understand what's going on in this situation here. This is a right angle, so therefore this must be a right angle as well. Remember, all the angles of a triangle must add up to 180 degrees. So what we're looking for here is, we've got 90 there, 22 there, so we need another, so we've got 90, we need another 90 out of this, so 90 minus 22 is 68. So still again, that's not in my triangle. So I need to find a different angle, and you should hopefully realise that the weight is always at right angles to the surface of the Earth. So this whole section must be a right angle, so therefore this angle here must add up to 90, it's 22 degrees. So this angle inside the triangle here is 22 degrees. Now, for the important part, we need to work out what our force down the ramp is using this vector triangle. So we need to identify the sides. We've already identified the 200 newtons as the hypotenuse. We've got our angle down here. So the side that we want to find out is the opposite. Back to basic trigonometry, SOHCAHTOA. So I'm going to use sine theta equals opposite over the hypotenuse. I want to find out the opposite, so I times both sides by the hypotenuse. So sine of theta times the hypotenuse equals the opposite. So in this case, sine of 22 times by 200 is going to equal my value there. So that's the first question. Now, what I want you to do for the lesson, work out what this value comes out as, and that is the force down the ramp. What I also want you to work out is the acceleration down the ramp. So we've worked out what the force is down the ramp. What would the acceleration be down the ramp? So I'll write that on the board. So question, what is the acceleration down the ramp? And we'll see what you get for that when you come in the next lesson.